Okay, we are going to attempt to figure out how to work geometric series within Khan Academy. We'll go ahead and start with watching the worked examples, and I guess I'll work through them while watching the video. Here we go.
So we're asked to find the sum of the first 50 terms of this series. And you might immediately recognize it as a geometric series. When we go from one term to the next, what are we doing? Well, we're multiplying by 10 elevenths. To go from 1 to 10 elevenths, you multiply by 10 over 11ths. Then you multiply by 10 over 10 over 11 again. And we keep doing this. And we want to find the first 50 terms of it. So we can apply the formula we derived for the sum of a finite geometric series. And that tells us that the sum of, let's say in this case, the first 50 terms. Actually, let me do it down here. So the sum of the first 50 terms is going to be equal to the first term, which is 1. So it's going to be 1 times 1 minus, let me do that in a different color. 1 times 1 minus the common ratio. So the common ratio here is 10 elevenths. 10 elevenths to the 50th power. To the power of how many terms we have. All of that over 1 minus our common ratio. And so I'm not going to solve it completely, but we can simplify this a little bit. This is going to be 1 minus, and let me put parentheses here just to make sure we're not just taking the 10 to the 50th power. So 1 minus 10 elevenths to the 50th power over, this is 11 elevenths minus 10 elevenths is over 1 over 11. And so this is the same thing as multiplying the numerator by 11. So this is going to be equal to 11 times 1 minus 10 elevenths to the 50th power. And you could try to simplify this even more, but this gets us pretty far. At this point, it is just arithmetic. Let's do another one of these. This is kind of fun. So this is more clearly a geometric series. And let's just first think about how many terms we're going to take the sum of. You might be tempted to say, okay, I'm taking to the 79th power. There must be 79 terms here. But be very careful, because the first term is when we're taking things to the 0th power. We're taking 0.99 to the 0th power. The second term is where we're taking it to the first power. The third term is where we're taking it to the second power. The fourth term is where we're taking it to the third power, so on and so forth. So this right over here is the 80th term. 80th term. So we want to find S sub 80. And so this is going to be equal to our first term is going to be 1 times 1 minus our common ratio to the 80th power, all over, and I'm leaving a blank because we still need to figure out our common ratio, all over 1 minus our common ratio. So at first, you might say, well, maybe the common ratio here is 0.99, but notice we have a change in sign here. And the key thing is to say, well, to go from one term to the next, what are we multiplying by? Well, to go from the first term to the second term, we multiply by negative 0.99. And then, so we're multiplying by negative 0.99. Now to go to the next term, we're again multiplying by negative 0.99. So the common ratio is not positive 0.99, but negative.
Okay, so I'm going to go ahead and stop him right there. And we're going to go ahead and attempt some of this ourselves. Give me a second to figure out how I'm going to do this. Literally the first time, so good enough. Now we're going to start with where he's at here. So we have probably should have worked some of this out before I started, but that's fine. So we got S sub 80 equals 1 times 1 minus common ratio to the 80th power over 1 minus, now he already explained, can you see my cursor? There we go. He already explained over here the common ratio is negative 0.99. So should be 80. So 1 minus negative 0.99. So that is minus a negative. So that'll be 1.99. So this straight cancels out. So we now have 1 minus, actually, let's see here. See, this is actually challenging. So let's see what he has to say about it.
Negative 0.99. So let me write that. Negative 0.99. And of course, that is going to be to the 80th power all over 1 minus negative 0.99. And so we could simplify this a little bit. This is all going to be equal to, well, that 1, we don't have to worry too much about that. And so this is going to be 1 minus, so negative 0.99 to the 80th power. Actually, put parentheses there to make sure we are taking the negative 0.99 to the 80th power. Well, we're taking it to an even power, so it's going to be positive. So that's going to be the same thing as 0.99 to the 80th power. And all of that over, well, subtracting a negative, that's just going to be adding the positive. So all of that over 1.99. And we could attempt to simplify it more, but if we had a calculator, we could actually find this exact value, or close value, actually. Most calculators don't give you the exact value when you take something to the 80th power. But this is what that sum is going to be. Let's do one more of these.
Okay, wow, so we got really, really close. The only thing that really needs to be done here is just get rid of that. And then that's his answer. So I took it a lot closer to where we were supposed to go than I had realized. So cool. All right, moving on.
All right, so here we have a series defined recursively. And so it's useful to just think about what it would actually look like. So the first term is 10. And then the next term, so the second term, a sub 2, is equal to a sub 1 times 9/10. Right? So the next term is going to be the previous term times 9/10. So it's going to be 10 times 9 over 10. And then the next term is going to be the second term. The third term is the second term times 9/10. So 10 times 9 over 10 squared. And the way it's written right now, I haven't written it as a finite geometric series. So let's say we want to take the sum. Let's say we want the sum of first, I don't know, 30 terms. Sum of first 30 terms. So what will this be? Well, we're going to take s sub 1, s sub 30. I don't know why I wrote 10.
Okay, so let's see if we can figure this out. First off, let me just get this cleared off here. Beautiful. Okay, so we want S. Let's see if I can write neatly-ish. So we want S sub 30 equals, so the formula is, say, division, right? So you know what I can do though? Since I have all this space, I might as well use it. Let's move this down here. We'll even make this larger. There we go. This is my very first ever video on here, so I do appreciate your patience with me, of course. And it looks good. There we go. So the way the formula works is it was 1 minus the common ratio. And then it's, let's see here. So we have 10 plus 9/10 plus 10 plus 9/10. So 0. So something, okay, so 10 squared is 100, right? So 10 to the first is 10. 10 to the 0, doesn't that equal 1? So why is there no 9/10 here? So that's, I guess, what I'm confused about. So this would be 9/10 to the first power, which would mean this would be 9/10 to the 0 power, but I thought that would be 1. So this should be like 10 plus 1. That's confusing me, but we'll just assume it's correct. So we have 10 plus how did that other one go? Hold on, let me flip back. This is why I always like to do these worked examples, because then you can show it. So back here we had 1 times 1 minus all of that over 1 minus all of that. So this, right? Oh, hold on, I have to click on my layer. So this right here is the common ratio. Which means so he took the formula being, it looks like s to the n equals 1 times, we'll call this r, r to the n over r. Because if you see, the 1 is part of the common ratio, right? Or was the common ratio just this right here? Now I'm confusing the heck out of me. Let's actually go back. Sometimes that's the best way to do it. So we're going to go back. Let's see here. So it was 1 minus 0.99 plus 0.99 squared minus 0.99 cubed. So in this case, 0.99 was the common ratio. So where did the 1 come from? Was the 1 on the first one? Let's take a look at the first one again. So the first one was 1 plus, 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 plus. So we have 1 times over 1 minus. So 1 times the first term minus the common ratio to the n over 1 minus 10 over 11. So 1 minus the common ratio. Okay, so that's 1s. 1 again. So, but the tricky thing about this one is the first term is a 10. So does that mean that my first term should also be a 10? So let's go back over to here. So I guess what I'm asking is, should that be a 1 or a 10? That I don't know. But what I do know is up here that it looks like this should be so going back again, right? So we had
over 1 over
1 times. So again, yeah, I guess it's the same question. So is this a 1 or a 10? Right here, is this a 1 or a 10? So we're going to just try it as a 1 times you know what I bet you? I bet you it's 10 times 1 minus, what was it again? 9/10. Let's see if that's how he sets it up.
A geometric series. So let's say we want to take the sum. Let's say we want the sum of first, I don't know, 30 terms. Sum of first 30 terms. So what will this be? Well, we're going to take s sub 1, s sub 30. I don't know why I wrote 10. S sub 30, the sum of the first 30 terms, is going to be equal to the first term. We've done this before. The first term times 1 minus the common ratio. 1 minus the common ratio to the 30th power. All of that over 1 minus the common ratio. And let's see, we could...
Okay, so looks like I was on the right track. I just made I was so focused on figuring out how to set up the problem that I forgot that we're looking at the 30th term, and this being the common ratio, 9/10. So we're going to real quick, we're just gonna erase all this crap. Go. Now we need to simplify. So going back to the brush here. So that equals so we have 10 minus 10 well, we don't need that print, so let's try this. Minus, wow, I cannot write neatly to save my life. Okay, so 10 times 9 to the 30th over 10 to the 30th over 0.1. So that's 1/10. Or we could write it as 1 over 10, which is the same as multiplying. So basically we put that over here and multiply this whole thing by 10, which means then we can get rid of all this fun stuff. Well, the 10 still stays there. So that's going to equal 100 minus 10 squared times 9 to the 30th over 10 to the 30th. And basically, you can just do that. So that leaves us with 100 minus 9 to the 30th over 10 to the 28th. And I have a feeling that's going to be the answer.
1 minus 9/10. This is 1/10 right over here. You divide by 1/10. That's the same thing as multiplying by 100. So this is going to be 100 times 1 minus 9/10 to the, well, let me write it this way, 9/10 to the 30th power. And actually these parentheses, you always want to, so I can put parentheses there, just make sure we see that we're taking both the 9 and the 10, or the 9/10, the whole thing, to the 30th power, not just the 9. So there you go. Yep, there you go. We're done.
Wait, hold up. So he ended right here. Okay, so we have 100 minus. So what he didn't do is distribute these 10s into that. He just,
there you go.
He got here basically, or no, he got right here and called it done. But whatever. I mean, it's the same answer. Because I can pull this back out if I just don't do this step. That's fine. So calling that one good. So we got a pretty good idea of what we're supposed to do. And on the next one, we might actually jump into the exercises. So that is going to do it for this one. Thanks for watching.